Oh, Garrett, you okay? Okay. So let's see what we can do here. We're given the length of RV is 12. And I would suggest that as soon as you find something, you just go ahead and if there's something else that you know, you go ahead and put it on the diagram. So what else do we know here? Oh, from the fact that this is 12, what do we immediately know? ST is also 12. Might as well fill it in. And they tell me that VT is 16. What else do we know then? Peter, put it away, please. RS is 16. We want to find the length of VX. Peter, your computer, put it away, please. It's distracting you. All right, so we want VX. VX isn't part of a right triangle, though, is it? So that kind of makes it a problem. But remember that the diagonals in a parallelogram bisect each other, and in a rectangle, they're equal to each other. So all those are the same length. So what I'm going to do is I'm going to focus on one of these bigger triangles and figure out how long VS is. So this is 16 and this is 12. And what can we use to find the hypotenuse here? Yeah, Pythagorean theorem. 16 squared plus 12 squared gives me the length of VS squared. 16 squared, 256. Isaac always knows those. Plus 12 squared, 144, is VS squared. Add those together, that's 400. What's the square root of 400? 20. So VS is 20. So how long is VX? Pardon? Other way. Yeah, it's 10. What? Did you say 10? You just have to, I mean, remember I'm half deaf, so you got to say it loud enough to where I can hear it. Just a word of warning on this. If you call this X or something, it's okay, but if you miss it and you called it X, and let's say you put 20 in the answer blank, I have to think that you think VX is 20, and it's all wrong. Okay, so to help you get partial credit, call it by name. Don't make up some variable for it, okay? That's just good for you. All right. So I'm going to have to draw a new one here. So R, S, T, V, something like that. And this is X. So it says SX is 10. What else do we immediately know then? We know what? We know VX is 10. What else do we know? I heard something but couldn't tell what it was. Was that you, Chris? What else do we know? Okay, yeah, we know VS is 20. RX is 10 and TX is 10. In a rectangle, all of those little pieces of the diagonals are the same. And they tell me the RV is 8. So what else do we know? ST is 8. And we're looking for the length of TV. So I'm going to use this big right triangle. It's a right triangle where I know two sides. I can use the Pythagorean theorem. 8 squared plus TV squared is equal to 20 squared. That's 64 plus TV squared is equal to 400. Subtracting, we have TV squared is 336. So TV is the square root of 336. What's the most obvious prime number that divides evenly into that? I think 3. 2 divides into it evenly also. You can start either way. Will 3 go evenly into 112? No, because the digits add up to 4. So I do have to switch to something else. So that's 56. 2 goes into 56 28 times. 2 goes into 28 14 times. 2 goes into 14 7 times. 7 goes into 7 once. So we've got a 2 times 2 times the square root of 3 times the square root of 7. So that's 4 square roots of 21. Any questions about that one? All right, let's do one more rectangle, and then we'll do some rhombuses. So they give you the measure of XVT. Let's see, this is XVT is 30. That's this angle down here at the bottom. We know a whole bunch of other angles at this point already, or should. Let's not worry about it just yet. ST is 8, so what else do we know? Yeah, RV is 8. Again, we're looking for XV, but XV is part of an isosceles triangle. It's not part of a right triangle. But if you look at VS, got this big right triangle. That's a right angle. This is 8. This is 30. Which side of the 30, 60, 90 triangle do we have? Do we have the short leg, the long leg, or the hypotenuse? Which one do we have? The short leg. Why? How do I know that's the short leg? Pardon? Say because it looks short? It's up across from what? Well, 30 is the smallest. So it's across from the smallest angle, so it's the shortest side. So this is S. This side would be s square root of 3, and the hypotenuse would be 2s. And this is VS. Well, that's what we want. VS is going to be 2 times 8 is 16. So if that whole thing is 16, each of the pieces is 8. I'm sorry?
Where'd you get 5 and 3 from? Or is that S and 3?
It's s square root of 3.
Yeah, where'd you get 3 from?
That's the formula. In a 30, 60, 90, the short leg is s, the long leg is s squared root of 3, and the hypotenuse is 2s.
Okay.
That's why I wanted to do this. We haven't done that in a while. All right, let's go on to the next page. All right, so we know that WY is 20. That's really hard to put on here. What would be the easier thing to put on there? Say, what, Andrew?
I've got to say like 10 for WA and then 10 for AY.
Yes. Thank you. Both of those are going to be 10. And it tells you WX is 16. And it tells us that this is a rhombus. So what else do we know?
That all the sides are congruent.
Yes, so they're all 16. Doesn't matter which side we're looking at. And we're looking for XZ. We're looking for this whole thing. Well, we kind of have the opposite problem of what we had in some of the rectangles. ZX is not part of a right triangle, but this is a right angle. So I can do the Pythagorean theorem and find out how long XA is, and then double it to find XZ. So 10 squared plus XA squared is 16 squared. So that's 100 plus XA squared is 256. Peter, are you with us? So XA, when we subtract and take the square root, is the square root of 156. I'm going to divide that by 3 first. That's 52. 3 won't divide evenly into that, so I'm going to switch to 2. 2 goes into 5 twice with 1 left over. 2 goes into 12 6 times. 2 goes into 26 13 times, and 13 is a prime number. So we've got the square root of 2 times the square root of 2 gives us 2. And I have a square root of 3 still left. And I have a square root of 13 still left. So that's 2 square roots of 39. Perfectly horrible looking number. If that's 2 square roots of 39, this is 2 square roots of 39 also. So then XZ, it's 2 square root of 39 plus another 2 square root of 39 is 4 square roots of 39. Gerson? All right, let's take a look at the next one. Is there a point in the middle of this one? A. Okay. So it tells us the measure of angle ZYX is 120. So that's this whole angle is 120. We know a whole bunch of angles now. If that's 120, what's something else that we know? Which one? Yeah. So this has got to be 60 and 60. And these all both have to be 60. Then they tell us the length of ZX is 30. So if ZX is 30, that's hard to write on here. What do we know?
15 for Z.
Yeah, it's 15 and 15. And we want to know how long ZY is. The only reason they're going to give you an angle is because it's going to help you figure out that it's a 30, 60, 90 triangle. The right angle is here, and that's a 30, 60, 90 triangle. The short leg is across from the 30-degree angle, so this is S. The 15 is S times the square root of 3. And ZY, what we want to know, is 2S. So S square roots of 3 is equal to 15. Divide both sides by the square root of 3. And rationalize the denominator. So it's 15 square roots of 3 over 3. It's 5 square roots of 3 for S. So then 2 times that for the hypotenuse is what we want to know, and that's 10 square roots of 3. So lots of opportunity for you to practice 30, 60, 90 triangles, 45, 45, 90 triangles, and the Pythagorean theorem on this. All right, last one. We have a square, and they tell us the length of CE is 16. Again, there are several other things that you know instantly from that. What else do we know?
All the sides are 16.
All the sides are 16. We're looking for the length of XB. Well, all the triangles in this picture are right triangles. More specifically, they're all 45, 45, 90 triangles. In the 45, 45, we've got 2 short pieces that are the same length, and the hypotenuse is S times the square root of 2. So S square root of 2 is 16. We'll divide both of these by the square root of 2. We'll rationalize the denominator. We get 16 square roots of 2 over 2, which is 8 square roots of 2 for SB. Any questions? Okay,